I'm involved in many European projects, maybe too much. So basically, I'm highly involved in 3 European and 1 Spanish project, and as I said, and a bunch of them that I'm not very involved, but as we are product owners, we do a lot of products, most of the products enter to most of the projects. So as I said, I'm not interested in published articles, but I'm really interested in developing different products. Now I'm focused in data discovery. Also, I'm a little bit half developer and half project management. In project management, as we have a lot of European projects, someone has to manage it. So I manage not quite a lot of them, but 3 or 4, so that's enough. And this means that I spend most of the time in online meetings. That, for me, is the worst thing in the world, because, as I said here in this comic, most of the times is time that you don't spend, like you don't do anything in this online meeting. So it's quite a shame that we do that much of online meetings, but okay, this is what it is. Okay, the life science infrastructure. Maybe you are asking yourself, so what is the life science infrastructure? For me, is supporting other researchers. So as you can see it in the Elixir website, that Elixir is the main infrastructure in Europe to life science infrastructure. So in their website, they have, we enable researchers to access and analyze life science data. So this is what I said, is support. We are supporting tools, we are creating platforms, databases, everything that you can imagine in order to help you to do your basic research. And I also asked ChatGPT, and it said the life science infrastructure is essential physical and technological framework supporting research and education in life sciences. So more or less, this is what I said. We have a lot of domains, so there are people focused in data, there are other people focused in tools. I'm more or less in this part, also in computing, so computing resources. We are from the supercomputing, I am from the supercomputing center, so we have to manage a lot of data, the security of this data, whatever. Also the standards, for example, if you are using, I don't know, the thing that I said before, the VCF. The VCF, you can have many other formats, like MAF, or there are plenty of formats for genomic variants. So there are some people that decide, okay, this is the best format to have genomic variants. You should use this format, more or less it is this thing. And also training, that is really important. So if I want to enter into some topic, I want to learn about any infrastructure, there has to be some people that teach you how to do it. And also, well, there are 23 countries, over 250 research institute, a lot of bioinformatics communities. So there are communities that has a high relation with Elixir, that is the European framework for life science. So for example, the rare disease group, they ask Elixir, okay, we would like to know if there is a platform to check our genomic variants without knowing who we are, because as we are so very few people, we don't want to lose our anonymity. So they have to ask that. And also there are many focus groups. I'm involved mainly in the machine learning group, inside the machine learning in synthetic data generation. And this is what we do at our group. Well, in theory we are 2 groups, but we are together, we do always the same things. This is my boss, Salvador Capella. And this is Josep Lluís Gelpí, that he will be one of your professors in this bachelor's, but he's doing biophysics, so it's not related with what I do. Basically, in our group, we are famous for open events, so benchmarking communities. I don't know if you know what is benchmarking. No? Okay. So if you want to buy a phone, I think you usually go to a website when you say, okay, I don't know if I want to buy an iPhone 9, I don't know how many iPhones there are, or this Xiaomi. So you look for which one has the best RAM, which one performs the best, which one is cheaper. So this is more or less, but for bioinformatics tools. We look at well, more or less the same. At the precision that they have, so if they perform well, if it takes a lot of computer memory, etc., etc. And also we monitor software. So we see if the software have their GitHub linked, we see if this software is fair, that means it is findable, accessible, interoperable, and reusable, I think it is. Also, we are the ones in Galaxy Spain that maybe they will do Galaxy here in the, okay, you will do Galaxy, so we are the owners of Galaxy Spain. That is a web-based platform basically to do workflows. So instead of putting the workflows in a command line, you can use it like in a web-based platform. Maybe you as a bioinformaticians, you won't use it too much, but for clinical researchers, it's quite good. Also, we have the open BRE, that this is a cloud-based working environment that allows you to rapidly build your own compositional platform. So when you are in your computer and you are dealing with, I don't know, 1 terabyte of data, your computer will explode. So instead of doing that, you will have some virtual machine. I hope you know what is that. It's like a machine stored in a server that is like a computer in a server. Okay, that's all that you need to know. So in order to do the workflows there, you can have your own computational platform, and this helps you to do these workflows in the server. And also now we are really focused in federated analysis. That basically, as the data cannot leave the hospitals, we have like create some kinds of guidelines and approaches where you have the data inside an hospital, you can send it. You don't need to send it somewhere. Instead, you send, for example, if you are creating an artificial intelligence model with this data, you only send me the weights of this machine learning or artificial intelligence, like deep learning weights. You send it in a central place, and then we normalize the weights in order to have a really good model with the data that cannot leave the hospital or the institution. And also, we are really involved in FEGA, so it's a federated EGA, a way where each country can store their biomedical data. We have QuiFX, that is a workflow orchestrator, so basically instead of sending jobs at your virtual machine, you can do it in your computer. You don't need to know that now. Also, with data access security, so for example, if you request data to an hospital or institution, you need to sign a lot of documents, they have to give you permission. It's a lot of bureaucratic stuff, but you need to do it. And also training, we train a lot of people in the multiple platforms, and we do the platforms per se. And yes, we are involved in more than 30 projects around Europe. This is what I do. I'm the beacon guy of my team. Basically, I'm developing the beacon network that's related to beacon, beacon on MOB, and beacon on top of CBio portal. I will explain later what is beacon. Also, I have to coordinate a project for standards in cancer called EOS for Cancer. We had last week a general assembly when it went really well, and we are trying that the different countries in Europe have the same variables, the same data, for example, for screening programs or for cancer registries. And also, as I said, I'm really, really involved in synthetic data generation, that I was commenting it before to Arnaud, and maybe it's a good point that you know what is that, because for sure you will have the same problems, you will face the same problems as me in the future. So what is the problem? You request data in an hospital, and the hospital won't give you the data. Why? Because they don't have time and resources. That's okay, but also because they have to pass to a lot of ethics committee. It's a mess to pass this data to my research. So instead of doing that, we create this data ourselves. So we have like sample data of these hospitals, and we try to generate this data that is not connected to anyone. So this data is completely anonymous. It's anonymous because it's artificial, and we can use it wherever we want. So that's a really, really, really nice problem that we have to tackle in the near future. We are starting to do it, but we are starting now. Also, now as I talking about Beacon, the discoverability of data, so I show you here two situations. In the current situation that we have now, so I'm a researcher, I want a data from this hospital, and I ask the hospital, okay, do you have a man in their 20s with lung cancer, for example? And the hospital says, okay, I have 1,000 other requests. First they do the other request, and then I can do yours. And you wait, you wait, you wait, you get older, and maybe they say, okay, we don't have them. So check another hospital, and you are already retired. But in this ideal situation, this is where Beacon enters. So each hospital already has a beacon, so they expose the data in a really, really anonymized way. So you check, yourself in a front-end page, like in a website. You check if any of these hospitals have the data that I need. So basically, you do a query in like, if it is like if you go to the Google, you ask, okay, I want a male in their 20s with lung cancer, and I can tell you, okay, these, and these hospitals have this data. You can request it. And then you do all the permission, all the data access committee that you need in order to have this data, because you have to do it for sure. It doesn't matter if you have the beacon or not. You have to pass all this bureaucratic stuff that nobody wants to do it. Oops. Okay, the main idea of the beacon. So you have the hospital. In the hospital, you generate all the data. You put it in a data lake. That data lake basically is a place where you put all the data. It doesn't matter if they are images, genomic data, phenoclinical data. It doesn't matter. You put it like in some machine somewhere. And with that, you generate the secondary use data of research. That basically is the data that you use in order to do research. So data where you cannot know who the person is already anonymized. So you put a beacon on top of it, and when you are looking for some kind of data, you ask the beacon asks the database, and it returns the data that, well, it returns the query. So if this hospital have the data or not. So more or less, I had given you here an example. So do you have a C instead of an A at chromosome 13 at this position? And you do this API query. That for now you don't need to know what is an API. Maybe it's too much for today. So you ask in the genomic variance models. You have the reference name with this. Oh, I can do like this. With this start position, the reference base, the alternate base, and the assembly. That it's, in theory, GR chromosome the 38, I think it is. So, and the beacon answer you a Boolean answer, yes or no. Also, you can do another type of queries. So what I say, in the hospital, which samples are a recurrent tumor sample from the female reproductive system, and the beacon can give you, it depends on the level of access that you have as a user. You have here your records. And this is the ontology terms that you have used. Ontology terms Yes, no? No, okay. Ontology terms are a code that are used to describe some term. So for example, the machines can understand it. So for example, sex, in Spanish sexo, in Catalan sexe. You have thousands of terms. You can say, sometimes there are some people that say gender. It's quite different, but there are people that does it. So instead of doing that, they put some code that means all these terms. Sex, sexe, sexo, whatever. And yes, and you have the ontology for the other term. And also, you can, if you have a different level of access, you can ask for how many female patients have recurrent ovarian cancer. And the beacon can ask the hospital and says, okay, 43, to say one number. Okay, what I'm developing now, it's a beacon of beacons. So you put a beacon on top of your hospital, and then you can put a beacon on top of the other beacon. So instead of asking just one hospital, you just ask all the hospitals in the world, for example. It's based on Java. We have a backend, and the ESCI, because we are we have a really good relation with the ESCI. They are doing the front end, and I presented at the conference in June, and it was quite a success. So basically, as you can see it, you can see it here. You ask for all these ontology terms. You ask in all the beacons that there are in the world. It doesn't matter. You can do a really little network. It depends on the number of beacons that you have, and it returns you the data. And we have 12 instances in the last prototype, and we are doing it for a lot of projects. This impact data is the Spanish one. This is the one from Kansas that I'm also the data manager. The project manager. I also manage this, and I'm involved in the European genomic data infrastructure. And this is a video of more or less a basic search. So this is all the beacons that we have in the network. And now I filter. I chose African with the ontology, the female with the ontology associated, and then cardiomyopathy with the ontology associated. So I search it, and the beacon gives me the results. So the Boolean answer is yes, the count is 12. The full response is all the anonymized data of these patients. So the individual ID is this one, it's African, it's from the Republic of Ireland, has these interventions, these measurements, and this disease, that is cardiomyopathy. So that's quite simple. It's quite simple when you see it now. Beforehand, it's not that simple. Okay, another thing that I'm only developing myself, but I think it would be nice to show it to you, is a beacon on top of an OMOP. As we see that it's really difficult to develop or deploy a beacon because you have to map all your variables from your data source from all the variables in the beacon specification, we thought that as a lot of hospitals use this common data model, that a common data model is like a model that you have already defined which variables are inside. So this model is very popular in hospitals, as this is what I say. The variables are really standardized. They are always the same. So it is really easy to share the data between the hospitals. And also, they really work with vocabulary, so with ontologies. They have all the synonyms, and you have a lot of things. So as we saw that a lot of people use this format, we put a beacon on top of it. So every time you ask a beacon, this beacon does the queries inside this database, and the database returns the data that you need. So as I had said here, this is me. I asked for female in the SNOMED term. I do a dynamic SQL query inside of the relational database of OMOP. So then I will know which patients have the data that I requested. It gives me the people in the database having these ontologies, and I return the results in a beacon format. yes, this is my take-home messages. So I know that you have to write your take-home messages, so you cannot duplicate mine. So this is my take-homes. This is more personal. So even if you are in the most successful lab in the world, the atmosphere between colleagues is one or the most important aspects. So it doesn't matter if you are in, I don't know who, in a one Nobel Prize lab. If you are not comfortable in this lab, just leave. Because you have to work there all the time, like 8 hours a day or more. And you have to be like a gusto. You have to be like you are in home in this place. Also, there are no natural paths, so you just don't need to do a PhD because your parents or your professors say that you have to do a PhD. If the PhD that you want to do really you think, okay, this is my path of the futures, okay, just do it. But you don't need to do a PhD because other people tell you so. So I don't have a PhD, I don't want to do it, and I know a lot of people that regret doing a PhD. So if you want to do a PhD, do it. It will be one of the best experiences of your life. But if you don't want to do it, it doesn't matter. Don't be shy. I really love going to conferences, especially hackathons, because, well, I love seeing new projects, and social part is the best. Maybe you don't know what is a hackathon. Hackathon is we spend 1 week in a camping. It's not a camping, but more or less. And we spend all day developing, there are many projects that you can sign. Well, you can assign yourself in some projects that are not related to your work at all. So you spend all the day working on it, you are coding all the day, and then you have a lot of social activities with other people. For example, this year, I'm a leader of one project, and basically, we want to parse all GitHub and see which tools are related to the bioinformatics fields. So now we have the API, we have all the GitHub from behind, all the metadata and everything, and we are parsing it, and we are creating a deep learning model in order to choose which ones are from bioinformatics and which ones are, I don't know, earth science tools. Also, when I finished my degree, I thought I didn't have the knowledge to be a bioinformatician. That's not true. When I did my internship, I had a postdoc teaching me, and sometimes I knew more than my postdoc. So don't worry at all. And also this is Mr. Wonderful, but do what you enjoy the most. So I really like this thing. I have been all my career path in this life science. I really like it, so that's pretty nice. And thank you. If you have any question?
Questions for sure. So first, congratulations. I think it's impressive. I mentioned it's 7 years since you started, but it's only 4 since you finished. And well, this looks like a whole career. So yeah, really congratulations. And also, it was a difficult talk. I mean, I was not really aware that. I mean, explaining all these infrastructure things to you that are just starting. So it's difficult. But I mean, now at least you can get a elevated picture of
a brief idea. Because for me,
we think very easy about. I mean, we say very easy. Oh, personalized medicine, variants, relation to diseases, but you need a lot of stuff behind.
And most of the people knows the infrastructure after they are doing research, because you go to the BDBI, that is a platform for where you can download the proteins and put it in PyMol. But this platform, you have to do it, and you have to have new extension, you have to code it, maybe this library inside the platform doesn't work. There is a lot of work behind it. And also, for example, we have contact with people in Uniprot. Uniprot behind it, it's crazy stuff. You have to do a lot of work there. So it's not, okay, all the things that you do, for example, Galaxy, that you will do it in the future. There are a lot of work behind it, and they are still doing, and they are still improving it every day. Yeah.
Okay, so time for questions. So we start as always with people in the priority list. Okay, I think it's a good. I mean, today we have plenty of time, so it's a good time for you to ask questions related to the talk, but also related to the path, if you accept
to my
them.
career or whatever. Yeah.
So who wants to start?
Okay.
So I wanted to ask that you have been doing your job for like 4 years or 3.
Yes. Yeah.
Have you ever regret? You say that you love data and all the things, but have you regret doing like some project that you have done?
Yeah, of course.
So
There are a lot now that I regret doing it.
But so the reason is because the data, or you had some problems that you have faced?
Most of the time is not having or not having the data, is what I said, having at the day 4 meetings, like spend 4 hours doing nothing, and just talking with other people, and these people doesn't complain with anything. At the end of the day or the end of the month, you have to do some real work, not only doing the meetings. And for me, it is what I stress the most. So yes, it's okay to do online meetings, but you have to do work between it. And yes, and also there are a lot of projects that you think, I don't know why I'm here. But you are there, you have to do something about it, even you like it or not. Most of them are pretty nice. There are no awful projects, but yeah, there are some days that I say, okay, I don't want to do this.
More questions? Yeah. They are a bit shy today.
Yeah.
To impress about the infrastructure thing.
What would you recommend us so as to understand how analyze data?
How to analyze data?
Yeah, in general terms. Which
how to generate?
Maybe what was for you the most important reason?
I like about analyzing data.
Purpose.
Well, at the end, you generate the data and you have to do something about that. So, for example, is a process when you start having a black box. So, for example, you have a FASTA file, you don't know what do you really have inside it, and little by little, you keep pre-processing it, you are analyzing it, and you extract some real results of this data. So yeah, I really love doing that. But especially the part that I like, that I said, is the thing before doing the analysis. So for example, an hospital gives you a data set. This data set, there are 2 hospitals. This is more easy. In one hospital, you have the variable sex and the other sex, and the values inside it, what is MF, and the other male, female. So you have to put all of this in a common ground. You have to clean it. There are a lot of variables that doesn't have anything. You have to match all the variables in order to test it together. So this is what I really like. And after that, you can do the analysis. And you have to think how to do the analysis and which tools you have to use that these analyses are really useful for anyone. Because doing the analysis in order to just by doing it, it's just a loss of time.
Well, you have mentioned that you did your Erasmus in the Helsinki University, and I wanted to ask if you think it's better to do the Erasmus on Europe or to go to America.
I didn't know that you could do the Erasmus in America. Okay, I don't know, but for sure you have to go to Erasmus. It's for me, and also all the other people that I talk that I have went. It doesn't matter if it is Erasmus or after the degree you go to do the masters to another place. Just if you can, just leave. In order, not because it is Spain, and Spain you know already what it is, but also because you see different people. I have a lot of friends from all over the world. And not only for the Erasmus, if not later, it teaches you that a lot of people are different, and in all this conference, you also met a lot of people of like everywhere, and you end up being friends with them. So yes, you can do it wherever you like the most. I choose Helsinki because I really like their program, so I look to all the options that I have, and the ones that fit me the most, so I really wanted to do something different. So for example, Bayesian data analysis, that is a really statistic thing that most of the people use for the pandemics, that is basically equations and putting 1,000 people in this equation to see how it interacts during the time. So I really like this, but I did it basically because it was different culture, and it is not like Portugal or Italy that we are almost the same. But I was ending up being friends with the Italian and Portuguese people from there. But it doesn't matter. The cultures are really different, and it doesn't matter where you go.
Here. Well, you've told us that you decided to go more towards the computing science part. When you started working, did you feel like you were behind, like for the fact that of studying bioinformatics or not maybe an engineer, informatics engineer or something like that? Okay,
yeah, I like this question. So I didn't feel at the beginning that I was behind, because as I went to the European Genome Phenome Archive, most of the people were or bioinformaticians or full stack developers, and I'm not doing now, and I won't do any like full stack. It's really bioinformatics engineering. But when I went there, I wasn't behind of anyone, because for now it's the beginning, but you will code here a lot. But when I say a lot, it's a lot of hours. And the only way to improve yourself is by coding and tests and errors. So no, you won't have any problem, I tell you for sure.
Since the first talk, we've heard a lot of about private startups and projects, and yours as well. Do you feel that not only in Spain, but worldwide, there's a lack of interest and investment from governments to research?
Okay, so I also work for a public place. It's not any startup of anything. So your question was if there are very few investment in the public sector, or
if you feel that there is small interest or small investment from governments.
Yes, because they don't want to invest money because they don't see really, or they are not really involved in the results that we do. But in reality, the only way for us to being alive is to put ourselves in a lot of European projects in order to have money. Because the only people that has money here is Europe. Spain doesn't have any money at all. So yeah, also we are also sometimes collaborating with private sector, but only as we are doing all these products, sometimes we cannot sell, even if it is free, these products to the hospital, so we need a private company in order to sell it. So yeah, there is quite a bit of collaboration, but yeah, there are very, very few investments, and this will be a problem, if not now, in the future.
Well, respect the beacon thing. You said that the hospitals don't give you the information at first, but how do you create the artificial structure that has all the information about the hospital? Okay,
so for now, for the hospital data, we use PDF with statistical information. So, for example, the one that we have taken now is colorectal cancer from the ACCR Jenny in the USA. That basically is a really large PDF saying For the colorectal cancer, there is an 80% of men, 20% of women. They have this percentage of this type of colorectal disorder for this other type. And they have, but amazing, they have a lot of statistics. And with that, we make a decision tree that basically it says, okay, if I create data, the 80% of the data will be male, the 20% will be female. Inside the male, there will be these percentages of type of disease. And inside of that, and also we have like random variables that create you like an electronic health record. So it tells you how many times this person has gone to a visit. So first they went to a visit because they had fever. Then in 2 visits later, they made him or her a biopsy because, yes, I don't know. And in this biopsy, they found that they have this tumor. And in this tumor, we have these treatments. We're doing all of this with statistics. And this is quite innovative. So I think we are the only ones that we are doing this now. So related with that, if you want to do some internship or your bachelor thesis in our group, just tell to me, or also use up USGLP, that is one of your professors. You can do it.
Okay, any other question?
Ja, crec. Ja.
Okay.
You told us you participated in many projects. Which was the one that you liked the most?
Okay, maybe the one that I like the most now is the Spanish one, because it's the one that gave me the opportunity to create the beacon on top of the OMOP, this common data model for the hospitals, and I have developed everything, so I had time for myself in order to do all the things, and I'm the one presenting it. I presented to the Global Alliance meeting last month, that is like a global thing from Canada, and it was quite a success, so I'm really, really proud of this thing.
My question is in referring to the beacon network that I believe is in development.
Yes, almost finished.
Yeah. Well, what is your plan of expansion? I mean, in what countries or regions of the world you wanted to use it?
So basically now we have a beacon network for Europe that they have 9 nodes. So it's Finland, Spain, Portugal, Germany, Luxembourg, Belgium, well, it doesn't matter. Then we will have another one for another project also in Europe, but in theory there will be people in Australia that are really interested. And last year there were, I think, 2 people from the government of Taiwan that also wanted to do it, so I don't know. But they have to do a beacon first before me putting on top of it the beacon network. So they have to do quite a lot of work in order to deploy their beacon before. But yeah, it doesn't matter who is doing it, but basically it's Europe and now Australia.
When did you realize biology wasn't your thing?
When I did my biology exams. No, I don't know. At the end is when you are doing the courses in the bachelor's, like you like one thing more than the others, and more or less you had the same proportion of like biology things, informatics. I only like more like programming and not studying like how the proteins work.
Okay, great. So let's thank again Sergi.
Cheers.
Okay, and since we are a bit early, you will start the class with a fit at 12 o'clock. Yeah? Okay. So yeah, you can move there. Bueno, molt bé.